Okay, ladies and gentlemen, number 46. F prime of -2. Let's use the first definition. This is just the limit as x approaching -2. And you see f of x is just that, so we can just put that here. 4x squared plus 3x, and then minus, we need f of -2. So let's put it on the side. Let's actually do here. F of -2 means we're plugging -2 into this x and that x. So we get 4 times -2 squared plus 3 times -2. This is 4 times that is 16. Yes, 16 minus 6 is 10. Yes, so this right here is minus 10. So f of -2 is 10. And then on the bottom we have the x minus a is -2. So minus minus becomes plus 2. Alright, cool. And now, if you take a look right here, doesn't this remind you of the algebraic limits that we did? Yes. Is there a fast way to do this? Yes, but let's do the things that we did earlier. Okay, I'll tell you, if you put -2 into all the x's, for sure you get 0 over 0. Why? Because we set it out to be 0 over 0. When we put a into this x and that x, it was f of a minus f of a, 0. A minus a, 0. Likewise here, 0 over 0. If you don't get 0 over 0, then that means you set it out wrong. Anyway though, how do we simplify this? We can actually just factor it. So let me see. Let me put it down on the side. 4x squared plus 3x minus 10. No common factor, so we'll just do a tic-tac-toe right away. So, you know the deal. We need to have x and 2 right here. 4x 2 times 4 will be -10, it's -5. Why does this work? We need to get rid of that, right? So that's it. But check this out. X times -5 is -5x, and then 2 times 4x is 8x. Together we do get a 3x that we want. Okay, so this is the limit as x approaching -2. On the top is just that, namely x plus 2 times 4x minus 5. On the bottom is still x plus 2. Over all, we see that this and that can cancel. Finally, put a -2 into here, and we will get 4 times -2 and then minus 5. -8 minus 5 is -13. Done. The limit as x approaching 3, right? We're following the first definition. We get x minus 3, and then on the top f of x is that, so it's just x over x plus 2, and then minus, we will have to put f of 3, yeah? So I'll just indicate that right here. F of 3 is just 3 over 3 plus 2. So it's just 3 over 5. So it's minus 3 over 5. Okay. As we can see, we have a complex fraction situation. Therefore, we are going to do the things that we did, right? That's why we talk about the algebraic ways to the limits. I'm going to multiply the top and bottom by this and that, so it's 5 times x plus 2, and likewise here, 5 times x plus 2. Alright, here we are going to get a limit as x approaching 3. Let me just keep them as how they are. So 5, and then x minus 3, x plus 2. Now let's multiply out the top. This times that, x plus 2 cancel, so we have 5x. Minus 5 and 5 cancel, but we have the 3 and also the x plus 2. Now, I didn't leave space on the top, so I'm just going to kind of do it on the side. So you see this is just 5x minus 3x and then minus 6, yeah? 2x minus 6. So this right here is 2x minus 6, and then we can factor out the 2, so it's 2 times x minus 3. Okay, so the so the top part is that. So let me just rewrite this. So we get 2 times x minus 3, and you see we can cancel things out on the bottom. So 5 times x minus 3, x plus 2. Very nice, huh? X minus 3 cancel. Now put the 3 into here. So we are going to get 2 over 5 times 3 plus 2. That's 5 times 5 is 25. So altogether we get 2 over 25. This is the limit as x approaching 2. And then here we have our function square root of 2x plus 5 minus, okay, we need the f of 2. So let me write it down here. F of 2 equals square root of 2 times that 2 and then plus 5. That's 9. Take the square root is 3. So it's 3 right here. And then over x minus 2. Aha! Once we set this up, it becomes what's that called? It becomes that algebraic limit question, right? So let's go ahead and just do the conjugate. Multiply the top and bottom by square root of 2x plus 5 plus 3, and then let's also do the same on the bottom. Square root of 2x plus 5 plus 3. Okay. Now, this is the limit as x approaching 2. Square this, so we just have 2x plus 5, and then minus 3 times 3 squared, which is 9, and then the bottom stays, so x minus 2 times all that. Alright, the top right here, let's just do it on the side real quick. That's 2x minus 4, and then we can factor out a 2, right? So it's this. So I'm just going to squeeze out the result here. 2 times x minus 2. Okay, and then I'm just going to cancel the x minus 2, x minus 2. Perfect. Alright, we have this 2 right here though, be really careful. So 2 over, put this 2 in here, so we have square root of 2 times 2 plus 5 and then plus 3. That's 9. Square root of 9 is 3, 3 plus 3 is 6. 2 over 6 is 1/3. Is it? Yeah. So this right here is the limit as x approaching 1. Function is x to the third power plus 4. And then we need to know the f of 1, right? So f of 1 is just equal to 1 to the third power plus 4, which is 5. So this means we have x to the third power plus 4 and then minus 5. And then on the bottom we have x minus 1. Yeah, it's not bad to factor this at all, so this is good. Limit x approaching 1. On the top is just x to the third power minus 1. And on the bottom is x minus 1. Okay, this is the same as 1 to the third power, so factor it. Difference of 2 cubes. We get x minus 1 times x squared plus 1 times x, so it's just x, and then plus 1 squared, which is just 1. And then on the bottom is x minus 1. And then x minus 1 cancel. Ladies and gentlemen, put a 1 here. 1 plus 1 plus 1. We get 3. Yay. Cool. Okay, f prime of x. Bring the power to the front, minus 1, we get 3x squared. Well, this is just a 4. But if you use the power rule, you can look at this as x to the 0's power. Put the 0 to the front. 0 times 4 is 0, so it's no more. So we just have this. F prime of 1. 3 times 1 squared. And we get 3. Wow. Wow. Powerful. Power rule. So powerful, isn't it? Here we go. Limit x approaching 9. Our function is 1 over square root of x. And then we have to minus f of 9, which is just 1 over square root of 9. And that's just 1/3. Okay, not bad at all. Okay, here we have 2 things to worry. One, we have a complex fraction. Yeah, small fraction instead of a big fraction. Second thing is we have square root. Yeah. By the way, let's take care of the complex fraction first. Multiply the top and bottom by this and that, so it's 3 square root of x. Okay. So we see this is the limit as x approaching 9. This times that, square root of x will cancel, so we have 3. And then minus 3 cancel, so we have square root of x. I'm just going to keep them as how they are. So we have 3 square root of x times x minus 9. Oh, hold on. This is square root of x. My bad. Alright. So for the top, I'm going to change the order of subtraction. This is negative square root of x minus 3. I switch the order and put a negative on the outside. For this, let's not do the conjugate anymore. So just look at this and then factor. We get square root of x minus 3 times square root of x plus 3. Alright? So now you see this and that cancel out completely. Very nice. So, ladies and gentlemen, on the top we have negative 1 over, here we have 3, and then here we have square roots of x. X is 9. That's gone. And then here we have square root of 9 plus 3. Yeah. And now we just have to work this out. This is 3 times 3 times 3 plus 3 is 6. 9 times 6 is 54. So altogether, we get negative 1 over 54. Done. So this right here is the same as saying x to the 1/2 power. But we can bring that up. So this right here is actually just x to the negative 1/2 power. Okay? And the reason that we want to do this is because we can use the power rule. Check this out. Put the power to the front and then minus 1. So we get f prime of x. And we get negative 1 over 2 at the front. And then x. This minus that is negative 3 over 2. Yeah. What's next? Well, we want f prime of 9, yeah? So f prime of 9. This right here gives us negative, yeah, let me just write it down. Negative 1/2, and then we have 9, and then to the negative 3/2 power. The main question is, how do we simplify this? If we can do it, then we are done, yeah? So, usual thing, put the power, right? If it's a negative power, then put it to the bottom. So this right here is negative 1 on the top over 2. And then once we bring this down to the bottom, we have the over 2 right here, right? Let's change that to a square root. And then we have the 9. And then raise that to the third power. So that's pretty much how you do it. Again, this negative, bring this down to the bottom. The over 2 power change to the square root. And then the third power stays. And you see, square root of 9 is 3. 3 to the third power is 27. Times 2 is 54. And that's on the bottom. All in all, negative 1 over 54. How cool is that, huh? If we want to do f prime of x, then we look at this right here and just replace the a with x and then still legit. Yeah, see? It's the official definition of the derivative. Here we go. We're looking at definition 2 and just change the a to x. That's all you have to remember. So here we have the limit as h approaching 0. And this right here, it's not easy. This is perhaps one of the first things that people dislike about the calculus part. It's pretty demanding, I would say. Anyway, we want to have f of x plus h. So what that means is, we want to look at all the x's here and then plug in x plus h. I'll show you. We will first get 3 times x plus h, and then square that, and then you continue minus f of x, so minus 5 times x plus h, and then plus 7. So that's the f of x plus h part. And then we want to minus f of x, which is just the original. So we just minus, and then we just put this down. 3x squared minus 5x plus 7. And you can see that this expression is pretty long already, and perhaps it's the longest, especially if it just come from pre-calc, and yeah, pretty intimidating. So ladies and gentlemen, f prime of x, this right here equals the limit as h approaching 0. We have f of x plus h minus f of x, and then all over h. And this is definitely a definition that you have to remember for your calculus class. Open this, we get 3 in the front, and then we have, let's just put this down in black, x squared plus 2xh, and then plus h squared. And then distribute it, we get minus 5x minus 5h, and then this is the plus 7. Distribute it, we get negative 3x squared minus minus becomes plus 5x, and then minus 7, and then all over h. But don't forget, we still have this to be distributed. Let me just put it on the top. Here we have 3x squared plus 6xh, and then plus 3h squared. Now, here's the best part. We can cancel things, hopefully. Let's see. 3x squared, negative 3x squared, cancel, good. Negative 5x, positive 5x, cancel, good. 7 minus 7, no more, good. This, and that remains on the top. And notice everybody has an h. We can factor that out. So we will. Here we have the limit as h approaching 0. Factor out the h. We get first thing 6x, second thing plus 3h, and the last thing right here we have the minus 5. Don't forget, we still have this remained. And then all divided by h. Now cancel out the h. And this is the reason why I told you guys you should keep writing down the limit as h approaching 0, or like whatever is approaching whatever, because now you see how we have both x and h in the expression, but it's only h is approaching 0, so you're plugging 0 into h. So this is like a reminder of what you have to do. You put h to be 0 in here, so you just have 6x, no more, and then minus 5. And here you have it. That's the answer. Derivative in action. Power rule, bring the power to the front, minus 1, 6x to the first power. Second part, minus 5x to the first power, yeah? Bring the power to the front, minus 1, so just minus 5. X plus 0, just 1. This right here, no x, so it's just a constant. The derivative of this is just 0, so done. So here we go. We want the limit as h approaching 0, and then this part means we're just plugging x plus h into here. So we have x plus h, third power, and then minus f of x, which is just that original, and then all over h. Open this, we get limit as h approaching 0, and let's use the Pascal triangle 1, 3, 3, 1. So first we will have 1 times x to the third power, so just x to the third power, plus 3 times x squared and h to the first power, and then plus 3 times x to the first power h squared plus h to the third power. So that's the expansion for that. And then minus x to the third power all over h. We can only cancel one thing. But the good thing is that you have h. Can factor that out, and we get 3x squared plus 3x h, and then plus h squared. Okay, and then you see that this h and that h cancel. Finally, put a 0 into this h and that h, so they are gone, and we get 3x squared. Done. F prime of x, limit as h approaching 0, right? If we cannot use the power rule, use the definition of derivative. Firstly, put the x plus h into here, so we have sine of x plus h, and then minus the original, just sine x, and then over h. Well, as I told you, whenever we use this definition, we will think about how to expand it, especially the bigger part, which is this. And we do have a way to expand this. This is just the angle sum formula for sine. And I'll tell you guys what the formula is. This right here, still limit as h approaching 0. We will first get sine of the first thing, which is x, times cosine of the second, which is h. And then we add sine of the second, so sine of h, times cosine of the first. So it's like this. And then minus sine of x and all over h. Cool. Impressive, but what do we do next? Well, keep this in mind. This is the limit as h approaching 0. So this is like in the h world, meaning that if you don't have h, like for example the sine x, you can actually put it on the outside of the limit and don't worry about it. So have a look. This term has sine x. This term also has the sine x. We can put them together and we can factor out the sine x and then kick it outside of the limit. So let's do two things right now. I'm going to pair this and that right here, okay? And then I'll factor out the sine x and then put it on the outside of the limit. So we have the sine x right here. And then let's look at the limit as h approaching 0. Here we'll just have cosine of h and then minus 1. And then over h, we'll still have that denominator. All right? And of course we have other stuff too. But for the other stuff is this over h, and then we can take the limit of that. So let's break it apart. Let's also put the cosine x outside. So I'm looking at this right now for the second part. I'm going to add cosine x on the outside, same reason, because it doesn't have the h. And then we just focus on the limit of sine h over h as h approaching 0. Alright? So the reason that we can do this is limit of a sum, it's the sum of the limits, so you can break them apart. And also, if you don't have the h, then you can put the expression on the outside of the limit. So that's why we can do this. Okay, this right here, we get 0 over 0. Likewise that. But you know what? This right here, we have seen it. Question number 5. So let me just remind you guys that, note, if we have the limit, earlier I used x, right now we have h. I know, I'm going to be using theta right now. I think it's like a more universal variable for this limit in particular. But anyway though, sine of an angle, sine of theta over theta, this right here will give you 1. And then you can see question number 5 for the graph. For now, this video I will just tell you guys, look at the graph that we have. Well, you can also just plug into calculator. I didn't do anything with the calculator in this video because it's just plug in the calculator, right? So you should be able to just plug into the calculator. But this right here, you please do not use L'Hopital's rule. What's L'Hopital's rule? Just wait for it. Anyway, what I'm trying to say is that this right here, per our discussion earlier, is 1. So we have this times cosine x. And then, what's this then? In fact, you can try it, multiply the top and bottom by conjugate, and use this to help you out. You can try it, but I will tell you the answer right here. You get 0. Or you can use the graph. Just use the graphing calculator. Use a calculator, plug in the numbers. That's not a discussion for here, but like that's equal to 0. So all we get what? 0 cosine x. Hey, the answer is just nicely equal to cosine x. I will show you we can actually use the power rule along with something called the chain rule, and then we can actually still formulate the easy way, the aka the so-called easy way to do this kind of questions. But let's do the definition of the derivative first. The limit as h approaching 0, f of x plus h. So we put that here, 1 over 1 plus parentheses x plus h. And then we square that, and then minus 1 over x squared, and all over h. Wow. It's a complex fraction with a lot of things. Anyway, multiply the top and bottom by this and that, so, oh, sorry, it's not just x squared, it's 1 plus x squared. Wow. Crazy. Hope you guys can see this. Okay, let me just fix this a little bit. 1 over 1 plus x squared. Ready? Multiply the top and bottom by this, which is 1 plus x squared. Also that, and perhaps I'll just multiply this out right here at the same time. So we have 1 plus, open that, we get x squared plus 2xh plus h squared. And then of course, let's also put that down on the bottom here. 1 plus x squared plus 2xh plus h squared. All right, so here we will have the limit as h approaching 0. Take this times that, this and that cancel, so we have the first part, 1 plus x squared, and then minus. This times that, this and that cancel, so we just have this. So I'm just going to keep it in the parentheses. We get 1 plus x squared plus 2xh plus h squared. All right? Cool. And then the bottom, maintain it. H times 1 plus x squared times 1 plus x squared plus 2xh plus h squared. Wow. I wish I can just copy and paste. Maybe it's easier that way, huh? Anyway, so we're just going to see what we can do. Check this out. 1 minus 1, this and that can cancel, yeah? 1 minus 1, because you have to distribute the 1. And then x squared cancel. So you see that we just have this and that left, and they both have h. We can factor that out. And it has a negative in the front. Let's keep the negative in the front as well. So we have the limit as h approaching 0, negative, h on the outside, and then we have 2x plus another h, like so. All right, and then all that stuff. H times 1 plus x squared times 1 plus x squared plus 2xh plus h squared. Yay. Okay, let's do this in our head. Put 0 into h, right? Put 0 into h. So we have negative 2x on the top. Over. Here we have what? 1 plus x squared, right? And then put 0 into h. So this and that cancel. We have 1 plus x squared. Whoa, look at that. It's a pretty clean result. This and that are the same though, so we can just put it as power 2, right? So negative 2x over 1 plus x squared and then square, and then we are done. Cool. And the reason now we want to do this is now we can use the power rule. Bring the power to the front and then minus 1. What do we get? F prime of x. We have the negative right here. And then the base, you keep it, which is 1 plus x squared. And then 1 minus, well, negative 1 minus 1 is negative 2. Okay, wow, look, I can bring this down to the bottom, and this is negative 1 over, this is 1 plus x squared and then square. Wait. I thought we could use the power rule, but I get negative 1 on the top right here. Earlier we have negative 2x. What's the deal? Is that wrong? That's wrong, huh? It must be wrong. The easy way is always right, huh? No. Definition is much better. Stall it. So here's the deal. How can we come up with the 2x? Well, we're in calculus, so we have to think derivative. Here's the deal. When we put the negative 1 to the front and then minus 1, we just do the power rule on the outside. And the idea is, you also have to look at inside to see what the function is and multiply the derivative of that. So you see the derivative of this, derivative of 1 is 0, but derivative of derivative of x squared is 2x. So we have to multiply this by 2x. So this is the so-called chain rule part, which is needed. So you see, if we multiply by 2x, altogether, we have the answer that we have earlier. So hopefully you guys can see why we need the definition of derivative. It tells you what has to be right. If you want to use the shortcut, well, earlier without seeing that, then we'll miss the 2x. First, let's do the legitimate way. F prime of x equals the limit as h approaching 0. F of x plus h, you change the x to x plus h. So you have the square root 3 parentheses x plus h, and then plus 1, and then minus the original function, which is just that. Let's just copy that down. Square root of 3x plus h, and then all over h. Okay, square root business, use the conjugate, right? So let's multiply the top and bottom by square root, and let's multiply this out. So it's 3x plus 3h, and then plus 1, and then plus square root of that, which is 3x plus 1. And let's do the same on the top, on the bottom. 3x plus 3h plus 1 plus square root of 3x plus 1. Cool. All right. Here, limit as h approaching 0. Open the top, right? Multiply on the top. We just get this square, which is just inside here. 3x plus 3h plus 1 minus this thing square, which is just 3x plus 1. And then the bottom stays the same, huh? So we have h times square root 3x plus 3h plus 1, and then plus square root of 3x plus 1. Ladies and gentlemen, 3x minus 3x, this and that cancel. 1 minus 1 cancel. Perfect. On the top we have 3 times h now. On the bottom here we have h times all that. So this h and that h cancel. Cool. Therefore we have a 3 on the top over, put 0 into here. So we have square root of 3x plus 1. That's the first square root. And now we actually have another one, huh? Wow. And they happen to be the same. And we're adding. Therefore it becomes 2 of them. So all in all, we have 3 over 2 square root of 3x plus 1. Done.